right, so we're looking at what is Cramer's rule and how we can use it to solve systems of equations. So we're going to start off by talking about determinants with matrix. Talk first about a second order determinant. It's still very cold outside, by the way. All right, so the second order determinant is a determinant of a 2 by 2 matrix. And it is calculated by as the difference of the products of the diagonals. So there's a couple of ways that you might see them ask you for the determinant. They could write DET before the matrix. Or they could just use straight lines. Both of these ask for the same thing. They ask for the determinant. And to find it, I'm going to take the products of the diagonals, so A times D, and find the difference, minus B times C. So the first example we're going to have is 5, -4, 8, and 9. And I'm going to do the products of the diagonals. So 5 times 9 minus 8 times -4. So that's 45 plus 32, which is 77. That's the second order determinant of this matrix. Questions? Right, so we're looking at 0, 6, 4, and -11. So we'll start with 0 times -11 minus 4 times 6. So that's 0 minus 24, which gives me a determinant of -24. Okay. Questions? All right, try this one. Come turn that off. Who's got their phone up here? On the board. All right, you're trying that one. That you understand how to find the determinants. Okay, so next piece, we're going to talk about third order determinants. So it's the determinant of a 3x3 matrix. And it's evaluated using the diagonal rule, and that's what we're fixing to do next. That's not right. I did this earlier. No. Oh gosh, just start over. Is that right?
Yeah.
Now it just all looks wrong. Good thing I'm not the spelling teacher, right? Okay, my next little piece is not going to fit in mine, so I'm going to have to change my paper. So I'll give you a second to get that third order determinant definition written down.
Which one are we going to use more often, the second or the third?
Mm-hmm.
Like about the same?
Yeah. So what we're getting to is that we can take and use this information to solve systems of equations without having to understand substitution, elimination, graphing. Okay. So this whole chapter is all about just different ways to solve those. Does that make sense? So you can solve by substitution, you can solve by elimination, you can solve by graphing, you can solve by this, you can solve by inverses, which is the next section. So all of them are just different ways to solve systems of equations. Okay? Everybody good? Okay. So let's talk about the diagonal rule. All right, step one. You're going to rewrite the first two columns of the matrix to the right. Rewrite the first two columns to the right of the matrix. Step two, we're going to draw diagonals beginning with the upper left element. And then we're going to multiply the elements in each diagonal. And you're going to repeat this process the second time, starting with the upper right element. Step two is really multiple steps in one. It's kind of the meat of the diagonal rule. Step three, you're going to find the sum of the products for each set. And by each set, I mean the left and then the right. And lastly, you're going to subtract the second from the first. So there's my determinant matrix that I'm using. All right, so step one, take both first two columns and write them to the right of the matrix. So 4, -3, -4, -8, 2, and 5. That's all you're doing is copying them. Starting with the upper left element, we're going to create a diagonal. And everywhere we can create a full diagonal, being 3 numbers, we're going to go ahead and do that. So it's going to be 3 diagonals. Everybody with me on how I created the left side diagonals? And I'm going to multiply the elements in each. So 4 times 2 times 9 will be 72. And then -8 times 6 times -4 will be 192. And then the last one will be 3 times -3 times 5, which will be -45. Okay? Everybody good so far? Okay. The next piece, we're going to go the opposite direction. And starting with the upper right-hand column, or the upper right-hand element. So I'm going to go this direction. There's 1, there's 2, there's 3. So I'm going to start with the -8, -3, and 9. And that's going to give me 216. The next one will be 4, 6, and 5. That will be 120. And the last one, 3, 2, and -4 will be -24. Everybody good? Okay. So that completes step 2. Okay. Step 3, we're going to find the sum of the products in each set. So note that I wrote mine in 2 sets here, the left side and the right side, right? So I'm going to add 72, 192, and -45, and that's going to give me 219. And then I'm going to add 216, 120, and -24, and that's going to give me 312. Then it says to subtract the second from the first. The first was 219, the left side, minus the right side, 312, gives me a difference of -93, and that is my third order determinant. The words looked more difficult, I agree. But at least they'll give you something to go back and guide you through if you can't remember which came next, right? All right, let's look at another one. All right. Step 1. Write the first 2 columns over on the right side. So -8, 0, 3, -4, -5, and 4. Okay. Step 2. Diagonals, starting with the left side. -8, -5, and 1. And go ahead and multiply those as I'm doing that. So that'll be 40. -4, -8, and 3 give me 96. And then 4 times 0 times 4. 0. Okay. Now starting from the right side, -4, 0, and 1.
0.
And -8, -8, and 4. That'll be a big 256. And then 4, -5, and 3. -60. Okay. Now what? Add the sets. 40, 96, and 0 will make 136.
Sorry, I was looking at the other one.
Okay. And 0, 256, and -60 make 196. And now I can take the difference of the first minus the second, and it gives me -60 as my determinant. Questions? Okay, you try this one. I got that on video.
Oh, really?
Yep.
Lovely.